Hey guys, this is the third video for Chapter 2, the polyatomic ions video. Now polyatomic ions are exactly what it sounds like. They are many atom and they're charged. So it's a group of atoms that have a charge associated with it. And there's a whole bunch of them. So here they are, memorize them, and good luck. That's it. Just kidding. There's a bunch of different tricks that I can show you to help you cut down on the memorization. The first trick, the first little mnemonic, is Nick the Camel. Okay, it's just a sentence. Nick the Camel ate a clam for supper in Phoenix. But it's an important sentence because it tells us a number of different polyatomic ions. So the first letter, or in chlorine's case, 2 letters, tell us the element. So nitrogen, carbon, chlorine, sulfur, and phosphorus. The number of consonants tell us the number of oxygens that are in the ATE ending of the polyatomic ion. So if we go back, we can see something like, I don't know, nitrate and nitrite is a good example of a difference, NO3 versus NO2. A lot of these just differ in the number of oxygens. So we've got something like NO3, NO2, and NO4 per nitrate. Those differ in just the number of oxygens. Now, they all have the same charge, which is really nice. And so these are all for the AT ending. So nitrate has 1, 2, 3, sorry, that should be the C, oxygens. And so let's take a look at, let's break this down and kind of talk about each one. So the first one is Nick, nitrogen. We've got 1, 2, 3 consonants, NO3, and I've got 1 vowel, and so that's NO3 minus, each of these are negative, and this, remember these are all the AT endings, so this is nitrate. Camel stands for carbon, we've got 1, 2, 3 consonants again, and 2 vowels, so we've got CO3, 2 minus, and that's carbonate. Okay, again, ATE ending. Clam, it's chlorine, it actually stands for all of the halogens, bromine and iodine as well. We've got 1, 2, 3 consonants, ClO3, 1 vowel, and that's minus, and so that's chlorate. You can follow this and do sulfate and phosphate. Now that's great. That tells us a number of them, but it doesn't tell us all of them. So what else can we do? Well, the nice thing is that we can figure out what the ATE ending is based on another trick called the common number of oxygen rule. Now the common number of oxygen rule says that in a box, or a little, I don't know what you call it, these guys right here, okay, those all have 4 oxygens in their ATE ending. Everything else, okay, everything else in this little border have 3 oxygens in the ATE ending. Well, that gives us something. I know that IO3 would be iodate. I know NO3 would be nitrate. I know TeO4 would be tellurate. But that doesn't get us all of them. So what else can we do? Well, going along with the common number of oxygen rule, if we know the ATE ending, we can find the rest of the endings and their numbers of oxygens. So the common number, the ATE ending, that's what we call the common number of oxygens. That's why it's called the common number of oxygen rule. So we're going to look at ClO3 as an example. So chlorate. If it's got 1 less oxygen, ClO2, this would be chlorite, 1 less oxygen than the AT ending. If it's got 2 less oxygens, ClO, that's hypochlorite. And if it's got 1 more oxygen, ClO4, that is perchlorate. And one more, again, we're basing this off of the AT ending, and we can get the number of oxygens for that AT ending based on the periodic table. Now notice that all of the charges are the same, right? Every type of chlorine-based polyatomic ion has just a -1 charge. That makes it very nice because we can go to the periodic table and kind of figure out some of the charges. So not only can we figure out the number of oxygens, but we can also figure out the charge. So looking at the periodic table, we know that I can tell you, I guess, that oxygen and fluorine don't make polyatomic ions, really. I mean, there's oxide, I guess, but there's nothing, there's a peroxide. But in order for this to work, we're going to ignore oxygen and fluorine. Now, once we do that, going to the left, we can figure out the different charges. Nitrate and nitrite and all of its different things would be a 1- charge. Carbonate is 2-. Borate is 3-. Okay, that's for this column. So 1-, 2-, 3-. Now we know chlorate exists, and that's a 1-. Sulfate, 2-. Phosphate, 3-. Bromate, 1-, 2-, 3-. 1-, 2-. Okay, so it gives us a lot of different charges. Silicate, of course, being our kind of outlier there. So we can figure out a whole bunch of different charges and a whole bunch of numbers of oxygen, a whole bunch of the AT ending, how many oxygens there are, and from the AT ending, using this little chart, we can figure out the number of oxygens for most of them. And so it gets us a ton of the different polyatomic ions. Now there's one more thing that can help. Sometimes if we add a hydrogen to a polyatomic ion that has a 2- or greater charge, we get a new type of polyatomic ion. So here we know from the previous slides that carbonate is 2-, right? And we know from the last video that hydrogen is a 1+. Putting these together gives me HCO3, and that one hydrogen cancels out one of the charges from the carbonate, and so we have HCO3-. And so whenever we do this, HSO4-, H2PO4-, whenever we do this, we add a bi to the front if we have one carbon. So you can say bicarbonate or bisulfate. Now we could add one hydrogen and get biphosphate, but you know, if we add two, we add dihydrogen phosphate, hydrogen phosphate is a good name for that. You can also call this hydrogen sulfate and hydrogen carbonate. That's fine. So that is a whole bunch of different. Now going back to our list here, that's a whole bunch of different polyatomic ions that we took care of. If we look, we have all of the different variables or variations for all of these nonmetals and their polyatomic ions, plus most of their charges. Using this little chart right here, most of their charges, nitrates 1-, carbonates 2-. So nitrite would be 1-. You know, sulfates 2-, sulfites 2-. All the charges are the same. And so we can figure these out. We can use these to figure them out. So unfortunately, though, there's still several that you have to memorize. So out of this chart, how many do we have to memorize? Boom. Not too bad, right? We have 7 that we have you memorize, and these are them: acetate, ammonium, cyanide, dichromate, chromate, permanganate, and hydroxide. Those are the ones I want you to memorize at least. The rest of them can come from the rules that we just talked about, the little tricks to figuring stuff out. Now, it may take you a while to get these down, but it helps. I promise. It helps quite a bit. It helps, you know, cut down on all of the different things that you would have to memorize. So, practice this. That's what the biggest thing with naming is. You have to practice, 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 practice. And we'll talk about compounds with these here in the next video. Well, let's look at just a quick example of a polyatomic ion and the name of one. So I don't know. Let's pick a weird one. We'll go from the formula to the name first. So why don't we do phosphite? Phosphite. And then we'll also do ASO3. Okay, that's 3 minus. I want to know the names of those. So going back up to our periodic table, we can look at this and say, okay, phosphite. It has an ITE ending. That means it has one less oxygen than the ATE ending. Well, phosphate, or phosphorus, is squarely in this little box that has 4 oxygens as its ATE ending. So if 4 oxygens would be phosphate, I know phosphite should be PO3. And if I go down here, I can figure out the charge. Starting with chlorine, 1 minus, 2 minus, 3 minus, that's phosphate, and it should have, that's the phosphorus-based polyatomic ions, and so it should have a 3 minus charge as well. So I know phosphite should be PO3, 3 minus. Now what about this other guy? We're given the formula. Now it's ASO3, so I can go back up to my periodic table and look at arsenic. Well, it's also squarely in this box that has 4 oxygens for its AT ending. Now my compound that I'm asking for is O3. If it's got 4 oxygens in its AT ending, that means 1 less oxygen, right? 3 is 1 less than 4, would end in ITE. And so I know that this guy should be arsenite. And so you can see, using these rules, we don't have to memorize anything, which is the beauty of it. Anyway, that's the discussion on polyatomic ions, and I'll see you guys next time where we will do compounds with polyatomic ions.